All right, so what I wanted to do was go through and do the coin changer kata using TDD and Rspec here inside of Atom. I already have everything set up with my gem file, my spec folders. Here I have a little terminal window running inside of Atom that'll let me run my tests pretty quickly here. And I have a custom command that will watch the directories, and every time I save the file, it should run the tests for us. So let's get started. First thing we're going to do is want to require our production code. So I'm going to go up into lib. And then we also want to require rspec. That's not how you do rspec. Okay, so that should work. So after that, I'm going to say let's describe changer class. So do end. What I really want here is a test, basically a smoke test. I want to just write something to make sure my testing framework and the connections between all the files are set up. So I saved this and it ran down here. I'm gonna make this a little bigger so we can see. And it's an uninitialized constant error changer. And that makes sense because we loaded this file and we said we were describing this constant changer, but we don't have one. So I'm gonna go over here to the production code. I'm gonna say class changer end, and now we should rerun the tests. And a little hard to see, but it ran them and said there's just no examples, so there's no tests, which makes sense. So here I can say it should do math. I'm going to say I expect that 1 plus 1 to equal 45. Okay, so we have a failure. I'm not quite sure why it's blue, but basically the problem here is that 1 plus 1 is 2, not 45. That makes sense. You really want to make sure that all your tests fail before they pass, just to make sure you're not getting false positives. So I changed that to 2, and now I'm waiting for my test runner to remember I've actually changed something. Okay, and now I get this little changer should do math, and it says I have 0 failures. So everything's working. I'm not going to actually keep this test because this is not related to what we're doing. So I'm going to say it, let's say it has a change method. So I'm going to say expect changer.new dot change to equal nil. Now this is a pretty basic test. If I had done some more time to plan, I probably would have thought of a different way, maybe to use the response to matcher that Rspec has, but I can't honestly remember the syntax off the top of my head. So we'll go with some more basic matchers here, just to kind of see the errors we get. So if we look here, it says that undefined method change for our changer class, which that is fine. So what I'm going to do here is I'm going to go in, I'm going to add in a method called change. I'm going to save the file, and then it should rerun our tests for us here in a second. It's a little slow. And there. So now we go back to this has a change method. So it's saying that the method does exist. Everything is working there. So that's good. So now we want to actually start to write some tests to actually demonstrate the functionality we want. So in the coin changer kata, the way this normally works is that we have this change method, and when we give it 1 penny, then it'll give us basically an array of 1 penny back. But if we give it 25, then it's going to give us 1 quarter. Then this gets really interesting is when you have something like 15, where it should give you back a dime and a nickel. It's basically supposed to always give you back in US denominations the smallest amount of coins possible. So 99 would basically be, let's see here, 25, 50, 75, 85, 95, 96, 97, 98, 99. So that would be the appropriate change for 99 cents. And we are going to be using tests to basically build out this functionality. And when you're doing anything with TDD, you want to follow the red-green refactor rules, and you want to make sure that you are starting with the smallest step, and you want to go from there. And that's kind of the hard part. The hard part is really knowing what the smallest step is, and it really just takes a lot of practice. So don't expect to get it right the first time, don't expect to get it right the second time, and don't expect to be able to not do it for a few months and then come back and then get it correct. For a perfect example of that, I have not used Rspec now in 5 months, using Minitest recently, so this will be a little rough just because I don't know, I'm thinking about it differently. That won't affect the way I do TDD, but that will affect the way I write my tests a little bit, because I'm trying not to just go back to the documentation this entire video. Okay, so let's write another test. So let's say it returns 1 penny for 1 penny. It's fine. So I'm going to say I expect changer.new.change1 to equal basically an array of 1 penny. Okay, so now we get an argument error where it says that our method, our change method right up here, only takes 0 arguments, but we are giving it 1. And that's perfectly acceptable. That's basically, we are changing the functionality from our first test to our second test, and now the tests are telling us we need to update our code. So to make this pass, I need to go over here. I need to allow this to take an amount, and I'm going to save it, and I'm going to see how that updates our tests. So that might actually give us a different error, and it does. This is a much better error. This is the kind of error that we're looking for here. So it says changer returns 1 penny for 1 penny. We expected an array of 1, but instead we got nil. So now we have to make this pass. So what's important to get into the habit of doing, especially if you are doing katas through TDD as a way of practicing getting better at TDD, is to only do the bare minimum required to make the test pass. And what that requires in this case is to basically just put that in. Our tests have not forced us to do anything other than hard code in the results. So what I did was I put that in there, and the test ran real fast, so you didn't really see that. But my returns 1 penny for 1 penny is now working. That is great. The problem is our original test is now failing, and it's basically failing for the opposite reason of the previous test, which is it's saying that this first test here is not giving it any arguments, and it requires an argument. Now, this is a common problem when you are first, learning how to use TDD. It can be very frustrating where you thought you were finished with this test, but you're not really finished because a further one has caused it to break. And the problem here is this test really doesn't care about the arguments. It really only cares that this method exists at all. So what we can do is Ruby has a method called, I think it's responds to. It might be respond. And I can say that I expect responds to change to equal true, because I want this method to return true. And now when the tests run, that's not the right one. So let's see here. Dot respond to uppercase. Okay, it's respond to. So let's just save that. Exit out of pry. Turn back on the watch. And let's run the tests here again. Okay, so now all of our tests are passing. So this is what we would call a less brittle test. We have both tests passing now. This is good. However, there is something that I do not like about this. I don't like that we have this changer.new happening in both of these places. So what I would like to do is kind of remove this duplication. And the way we do this idiomatically inside of Rspec is to use something called a let. And a let is more or less somewhere between a variable and a method. It's a way of extracting out some duplicate code from your tests to make them a little bit drier, just to make testing a little bit easier. I try to use them sparingly. You don't want to go overboard with these. It could definitely cause problems with your code base down the road. So this allows me to just get rid of all of that and then just put changer here. So it'll basically new up an object for us before every test runs, which is kind of nice. And we can make sure our test did not fail when we did that, and they did not. So we are good to go. So let's keep writing tests. So the next one I want to do is I want to make sure it can return multiple pennies. So I'm going to say it returns 3 pennies for 3. And I can say that I expect change of 3 to equal an array of 1, 2, 3. Okay, so now we can no longer hard code a response. The specificity of our tests have basically said that we now need to make our production code over here more general, more less specific. We can no longer be hard coded. We're going to have to use a variable or something else. So we have to figure out a way. So right now we know that amount is equal to 3, but we want an array of 3 1s. So we can try a few things here. Let's see if this will work. Hey, and that did work. So if you're wondering why that worked, let me just open pry real quick. So the reason why that worked is because in Ruby, if you have an array and you multiply it times a number, it basically just creates an array with that number that many times. So if I say, you know, I have a string of foobar and a string of baz, and then we multiply that times 2, we get the same array twice. So it basically is just duplicating that array that many times. It's a nice convenience method to save us some looping on our end. So that's going to make this code a little bit cleaner. Hopefully the whole time. Maybe it only works for this test. We don't really know until we write more tests to keep going down the same road. And what's worth noting is that it's very hard without extensive practice to write the same tests every time. You're in a different mindset. You've learned some new things. You've tried some new things. So you'll write your tests differently, and that will affect the way you write your production code, which means you might come out with a different outcome every time, especially if you are letting the tests drive you as you are normally trying to do during TDD. So let's write another one here for returns 5 or 1 nickel. I think that's how you spell nickel for 5. So if I'm going to say I expect changer.change 5 to equal 5. All right, so let's get rid of this terminal, go back to this one, and it hasn't run the test yet. There it goes. So it gave me 5 pennies, which is really interesting because in certain regard, the apps, it still works. The method still returns something that makes sense, but it's not our desired finished output. We really want to make sure to clean this up some more. Okay, so what we need to do is we need to make sure that we are returning for nickels, not just for pennies. So what I'm going to do is I'm going to use what's sometimes called a guard clause or a short-circuiting return in a different way, not the traditional way you normally see them used. I'm going to return 5 times the amount if the amount is greater than 4. So I'm basically saying if it's less than 5, then it can't be a nickel. It has to be pennies. So then we're just return the pennies. But if it's greater than 4, then do the same code with nickels. Although we see a problem here, which is that this exact code is going to return an array of 5 5s. And that's really wrong. We would be fired very quickly if our application was giving out 5 times the amount of change it should be giving out to customers. So we should look at adjusting this. So the problem here is that we're multiplying it times 5, but we really need to multiply it times how many times our amount goes into this. So we should say 5 amount divided by 5. That should give us what we want. There we go. So all of our tests are now passing. So nickels are interesting. This is the one thing I know from doing this kata several times, is that my next gut reaction is to say I need to return 2 nickels for 10. However, that is a test that will immediately be wrong when you get to dimes, because 2 nickels is 1 dime. And there's actually very few situations in this entire kata where you're ever going to need more than 1 nickel for any one situation. And that reflects how it is in real life. If you're trying to give someone the smallest amount of change, dimes and quarters will always take precedent over just nickels. So I'm going to kind of skip that dead end, as it were. And I'm just going to move on to testing dimes. So I'm going to say here, so it returns 1 dime for 10. So here we go. So say expect changer dot change 10 to equal 10. Okay, and we're going to wait for this to fail, and it does because we got 2 nickels. It's all basically working the way we expected. So I'm going to use roughly the same code I had before. I'm going to say return 10 times the amount divided by 10 if the amount is greater than 9. Okay, so if we can get this to run, we should see everything passing. Great. So this is working wonderfully. I think we've already basically run into a pattern that works for all of the increments that we'll be using. So if I say return 2 dimes for 20, and I say that I expect changer change 20 to equal 10, 10. I expect this to probably just work. Yeah, and there it goes. Great, so let's be thorough and let's finish this up for quarters. Now that we have all of these passing, we need to work on the case where we have mixed amount of coins. So it would be easy to jump straight for 99, which is kind of our big test at the end to make sure everything's actually working. But I don't want to jump straight to that next, because that isn't the smallest step. That is really a quite big step, honestly, from where we are right now. So what I'm going to do is I'm going to just have anything with mixed. So let's say it should return 2 dimes and 4 pennies for 24. Makes sense, right? Okay, so we're going to say we expect changer change of 24 to equal an array of 10, 10, 1, 1, 1, 1. And now what we're going to see is, well, first of all, it's going to be wrong. So we see here that it only gave me 2 dimes and left off the 4 cents entirely. And the reason why is we kind of coded that where it always just returns immediately. So this pattern I was using to solve this problem is no longer a solution. And that's fine. I didn't TDD it wrong. It doesn't mean my code is bad. It just means that we need to change it. And this is good because we have tests to make sure we don't break previous things we've done. So what we basically need to do is I need to save these amounts into an array. and then return it at the end. Most straightforward and least invasive way I can think of doing that is just creating a return value, which will be return amount, and I'm going to set it to an empty array. And then what I'm going to do here is I'm going to basically say return amount, and I'm going to shovel in the results into each of these. So one thing I'm noticing right now is I'm going to have to also put an if statement here. I think if amount is greater than 0. And then let's just return the amount. And let's just see what happens. The best thing we need to do is we need to make sure we're running the tests all the time. If we start to think too much about it and take too big of steps, we will get really out of sync with our tests and we won't really know where we are. So as you can see, that actually broke every test. So if we go look here, now it's returning 10, 10, 5, 5, 5, 5, 5, and all the ones. It's returning basically the right change for every single increment, because now if we look at these if statements aren't mutually exclusive anymore. Before, it ran one if statement and it left. So now it runs all of the if statements. So everything's being combined together, and this is just not going to work. So we need to think of a better solution. We are in luck because we have all of our tests here to make sure that everything is okay. As I look at this, I see a lot of repetition here that doesn't seem to be needed. We've got magic variables here. What I'm seeing here is I'm basically seeing a loop of all of the coins with the same if statement and the same coined variable happening again and again. So what I'm going to do is I'm going to remove all of this for now, and I'm going to rewrite this into a loop. So I'm going to say I have 25, 10, 5, and 1, which are our coins. And I'm going to say each do for the coin. And then I'm going to say return amount shovel the coin times the amount divided by the coin. And I'm going to say that I should only do that if amount is greater than or equal to the coin itself. So hopefully that makes sense. Okay, so let's rerun these tests here and we'll just see what we have. All right, so everything is still broken. Actually, it's saying undefined method division for array. That's interesting. Why is it saying that? Oh, so that has to do with operator precedence. So what's happening here is Ruby is doing this part first. So it's multiplying the array times the amount and gives us that big array we saw before, and then is doing division on it, so you can't divide an array. So what I just need to do is I need to kind of force the operator precedent here by wrapping that in parentheses to say, no, you need to run this first, and then after this has resolved, then run this multiplication here. Okay, so I don't expect that to actually fix everything. I just expect to get a different error. Hopefully a slightly more useful error. Okay. So basically we have the same results we had before, which is we have a big nested array of all the results. That's not mutually exclusive. And I think the problem here is that even after it's added all the quarters or added all the dimes or added all the nickels, the amount asked for is the same. So the amount that we ask for gets passed into each coin increment and doesn't go down. I think that's really the problem here. So what I need to do is I need to actually say that the amount, we should subtract, the amount should equal the amount minus how many coins we used. And how many coins we used is amount divided by coin. times coin. Hey, that looks right. So now we have the right amount of change, but all of our tests are still failing. And if you see, the problem here is they're all wrapped in another array because we have an array that we're creating up here, and then we have a bunch of other arrays that we're creating down here, and then we're all shoveling them together. So the fastest way of fixing this is just to add a flatten here on the end of our returned amount, and that will just tell Ruby to just remove all the internal arrays because we don't really care about those or want them. Now, obviously, this is a really naive solution here, and is probably not very fast, but that's not really our intention when we are doing TDD. When we're doing TDD, our intention is to write tests and have those kind of guide us to a solution, and then we can focus on refactoring later once we have a passing test case. Okay, so all the tests are now passing. That was basically what we needed to get everything working. So I'm very happy about that. So let's go write our last spec for this, which will be the 99 cents, and then just make sure all of that's working. So let's see here. So it returns 3/4, 2 dimes, and 4 pennies for 99. So let's see here. So 1/4, 2/4, 3/4, and then 75, 85, 95, 96, 97, 98, 99. So there's our change. We expect that to actually work. And it does. So all of our tests are passing. So that is awesome. So with all of our tests passing, let's look at what refactoring opportunities we have. So let's get the tests kind of out of the way for now. Don't even really need them open right now. Let's get rid of these comments. We don't want to leave comments around. So this is our finished solution. I'm not super happy with it. There's definitely some things I would like to change. There's some duplication here, but overall it's not bad. It does convey the intent of what's actually happening, and you can follow the logic through the each statement and this multiplication here. This is interesting how similar this code is here between these two lines, which means there's probably something that we can abstract into a private method or something similar to make this aspect more clear. All right, so that is probably enough for this video, which is a lot longer than I intended it to be. Hopefully you found it helpful.